momentito aquí, o si ya tengo mi... Ah, sí, ya tengo el micrófono abierto. No, pues para mí es realmente un gran placer, un gran honor hacer parte de esta celebración de los 25 años. Como buen hermano menor, entonces los hermanos menores siguen los ejemplos de los hermanos mayores, ¿no? O sea, bueno, yo realmente tenía pensado arrancar de una vez con la parte técnica de mi charla. Pero al ver el buen ejemplo que marcó Frank ayer y que han seguido los demás, me tocó pues seguir ese buen ejemplo. Sin embargo, también aquí voy a aprovechar el hecho de las ventajas que tienen los coorganizadores de saber de que, bueno, cuáles son las otras sesiones que tenemos y tomar ventaja de eso para gastar un muy reducido tiempo en esta parte, decirles que realmente el agradecimiento que le tengo a todos ustedes, a Avispa, es inmenso. Prueba de ello es que tengo aquí media familia escuchando la charla, porque he logrado transmitir ese agradecimiento en mi familia también. Y bueno, sí, o sea, yo soy convencido de que las imágenes dicen más que 1000 palabras. Entonces yo mañana tengo como varios miles de palabras para compartir a través de imágenes y de expresar mi gratitud. Sí, sin embargo, bueno, aquí nada más estoy mostrando como un appetizer, sí, de lo que viene mañana. Sí, y Frank, bueno, realmente el que quedaste asignado como chair de esta sesión no fue algo hecho al azar, fue algo hecho a propósito. Realmente quería tomar ventaja de esta oportunidad para darte las gracias por conectarme con Camilo. Y después, obviamente, a través de Camilo, conocer a Juan Francisco. Sí, o sea, para los que no conocen, y esto de pronto puede ser difícil de creer si solamente ven las apariencias. Sí, o sea, yo soy 2 años menor que Frank. Claro que él se mantiene así vuelto un chacho y entonces da la impresión de que más viejo soy yo. Claro que, bueno, también si ustedes ven el CV de Frank, ahí se dan cuenta que sí tiene que ser mayor, pero de todas maneras, sí, Frank es 2 años menor que yo. Y cuando, bueno, muchos años atrás, Frank fue mi monitor de lo que se llamaba en esos tiempos lenguajes 2, o sea, paradigmas de programación, ¿sí? Y Frank fue la persona que a través de esa monitoría, bueno, primero me transmitió esa pasión por Prolog. Sí, yo recuerdo que él lo enseñaba con tanta pasión, explicaba con tanta pasión que eso, mejor dicho, me impregnó y realmente me vendió la idea de que yo podía ser bueno en eso y me conectó con Camilo. Dijo, vea Camilo, este negrito es como bueno, le va muy bien, le va muy bien conmigo y tal cosa y tal otro. Yo creo que puede ser un buen candidato y ahí fue que bueno, realmente sí, ya Camilo me adoptó y después conocí a Juan Francisco al mismo tiempo y todo eso. Entonces quería resaltar ese pedacito. El resto, el resto del chorro lo he hecho mañana. Bueno, para contarles muy brevemente mi historia, ¿no? Bueno, yo soy de Buenaventura. Sí, bueno, aquí están mis padres. O sea, mis padres no han sido personas así adineradas, pero nunca escatimaron esfuerzo para darnos la mejor educación a los hijos. Mi hermano también está por ahí lo veo. Sí, y claro, o sea, pues yo terminé, después de hacer mi bachillerato, pues terminé estudiando en la Javeriana por ese hecho. Sí, recuerdo que era el único negrito allá. Claro, y de todas maneras, pues sí, me hacía un tanto notorio por ese hecho. También, y bueno, y después se dio pues toda la historia en AVISPA, que mañana tendré la oportunidad pues de profundizar un poco. Sí, gracias a AVISPA pues se me abrieron las puertas pues en el exterior. Hice mi doctorado en la Universidad Católica de Lovaina. Bueno, en Bélgica estuve del 2001 al 2006. Sí, mi maestría la completé en el 2004 y en el 2006 me doctoré. Y después, en el 2007, arranqué para acá. Entonces, inicialmente el plan eran venir acá por 2 años y bueno, nos resultó gustando esta vaina acá con Lucía, mi esposa. Sí, entonces, pues bueno, ya nos adaptamos, nos empezamos a sentir bastante cómodos en el laboratorio y todo eso. Y bueno, después ya sí, empezamos a echar raíces, pero nunca sin olvidar nuestros orígenes. Y es por eso que hemos tratado de mantener esta relación candente pues con el grupo, ¿sí? O sea, pues Camilo, Juan Francisco saben que siempre que yo voy a Colombia, pues, o sea, trato de entrar en contacto con ellos, ¿sí? Bien sea formal, a través de una visita en la universidad, o bien sea informal, como lo demostrarán las fotos. Ah, bueno, y como está esa foto allí, esa foto nos la tomamos en este año, precisamente en la última ida a Colombia. Sí, y entonces, sí, o sea, siempre, como decía Camilo, pues, o sea, pues empezó siendo mi jefe y bueno, y ahorita y lo mismo Francisco y obviamente lo mismo, obviamente Frank y todos los de Avispa, o sea, son muy amigos. Tanto es así que me lo tomo en serio que yo cuando viene alguien acá y no me saluda, mejor dicho, es inconcebible para mí que venga alguien en Irlanda y no llegue a mi casa. Sí, entonces eso es motivo para dañar la amistad. Para que lo tengan en cuenta los que no han visitado todavía. Entonces, bueno, entonces,
con los Gustavos todos dormimos ahí en Bélgica en tu casa.
Así fue Carlos, sí, así fue Carlos. Exacto. A propósito, papito, el que habló y el speaker de la charla anterior era Carlos, el de la foto de que nos tomamos con Peter Van Roy hace 15 años. Y no que ahorita el tipo ha cambiado bastante, pero es el mismo Carlos. Bueno, entonces, bueno, ahorita sí déjeme, bueno, entonces, ahora sí, yendo a la parte técnica. Entonces, la parte técnica la voy a hacer en inglés. Y como les decía a mis colegas, no la hago en inglés porque crea que mi inglés es muy bueno, realmente, y honestamente, como se lo he dicho a varios, incluyéndose al mismo Robinson que aprendió su cámara allí. O sea, hay gente, la mayoría de mis colegas pienso que tengan un mejor inglés que yo. Lo hago precisamente por lo siguiente. Porque realmente, y si ustedes se ponen a analizar ese archivo que creamos, que Fran nos invitó a crear y que ahorita ya reportan como 40 miembros activos, como el 75% de los miembros que tenemos allí están ubicados en el exterior, ¿sí? Y obviamente ahorita el problema no es de plata, ¿sí? El problema no es de que no hay plata para financiar doctorados en el exterior, ese no es el problema. Ahorita realmente el problema es conseguir estudiantes y eso es una realidad que todos la sabemos, ¿sí? ¿Y cuál es el principal inconveniente que tenemos allí? El principal inconveniente que tenemos allí es que nuestros estudiantes no tienen un buen nivel de inglés, ¿sí? Y entonces, y eso es lo que pues básicamente hace que todo ese potencial de becas que tenemos en Irlanda, en Australia, ayer listaba Julián un poco, y en fin, o sea, y en Francia y en todos los otros lugares se nos están desperdiciando porque la gente pues simplemente no tiene el nivel del idioma. Entonces yo sí soy de los que creo firmemente que tenemos que hacer un esfuerzo para incentivar a nuestros muchachos a comunicarnos más en inglés. Y por eso lo hago, no porque mi inglés sea bueno, es porque es mi forma de incentivarlos a los demás. ¿Ok? So now, let me see. So now we switch to English. So my talk is going to be, well, I already told you, it's about preferred minimal conflicts and relaxations, from 2-point relaxation to multi-point relaxations. So now, during the first part, it's going to be very basic, and it's actually going to be based on this paper from Juncker. This paper was selected as the recipient of the AAAI 20 Classic Paper Award. So it's a paper from 2004, but actually now that XAI has become such a hot topic, it has gained a lot of popularity. So yes, actually, most of the samples that you are going to see during the first part, I am basically taking those samples from this paper. So don't be so disappointed when you go to the paper and see that, okay, this is pretty much what I already presented here. So, well, I find this paper very intuitive. So suppose that there is a customer that wants to buy a car, and he is interested in 5 features. So yeah, he was a roof rack, CD player, one additional seat, and so on and so forth. And for each one of those features, or those options, okay, there is a cost associated to it. Of course, there is no free lunch. So yes, for the first one, we have to pay 500 euros, and for the second one, 500 euros, and so forth. Okay, so now, okay, from now on, we are going to use K to refer to the cost. We are going to use X to refer to the indicator variables. You know, so well, basically x1 is equal to 1 means, okay, we are selecting that feature. Yes, yes, of course, you don't need to be a genius to realize that because yeah, we have a budget of 3,000 euros. With that budget, we cannot have it all, isn't it? And for example, if we start propagating in the order of the features or requirements, as I am going to call it further on, we see that, okay, we add the first feature is okay, we are still under the budget. If I add the second feature, yes, still under the budget, and so on and so forth until I get to row 5. And there, of course, I get a failure. And then you can say, well, that is an explanation for the failure. The failure, the explanation is you cannot have row 1, row 2, row 3, row 4, row 5. And indeed, that is an explanation, but it's a very unsatisfactory explanation, isn't it? Because there are several elements in that explanation that are not relevant. Okay? For example, now suppose that we are considering the requirements in this order. So now we are considering first X4, requirement 4, and then requirement 5. And then PAN, okay, we get to the failure. And indeed, now we get a more compact explanation for the failure. So yes, you cannot have them all because row 4 and row 5 are already taking you out of the budget, isn't it? And the thing is that once you identify a conflict, if you want to end up with something that is satisfiable, you have to resolve it. And our way of resolving the conflict is just dropping one of the requirements. That's it, isn't it? And then suppose that now we know that, okay, there is a typo there, that row 4 is, no, that's actually okay. Okay, the row 5 is more important than row 4. So in that case, in order to relax the first conflict, we just get rid of row 4. But again, we get another conflict, row 3 and row 5, because the sum of those two items, the sum of the cost of those two items are going to bring us above the budget. Okay, so then in that case, if we know that row 3 is more important for us than row 5, what we are going to do in order to get something satisfiable is to get rid of row 5. And then we get something that is satisfiable, row 1, row 2, row 3. But what is the issue now? The issue now is that because of the order of how we consider and resolve the conflict, we end up with a relaxation that is not maximal. You know, so yes, indeed, we know that row 1, row 2, row 3 are satisfiable, but still it is possible to have another item, row 4. And that's the thing that we are going to focus in the rest of this talk. So suppose now that we know that we already know that row 3 and row 5 is a conflict. We already know that row 4 and row 5 is a conflict. Now what we want to define is what is more important for us. Well, between these two conflicts, because that's the thing that I really want you to get from the very beginning. If you have an unsatisfiable CSP and a set of conflict explaining that as an unsatisfaction, you have to resolve all the conflict in order to get something satisfiable. And then if you need to face all of them, then the idea is to take care first, to choose first the conflicts that are more important to you. You know, and the conflicts that are more important to you are the ones that involve the most important requirements. Yeah, because that is going to bring you to the more to the decisions that are more difficult to take. You know, so if we need to solve this conflict, row 3, row 5, and we need to solve the conflict row 4, row 5. For me, solving the conflict row 4, row 5 is pretty easy because it's involving requirements that are not so important to me. So actually, I don't care much about losing any of those because, you know, they are not that important. But row 3, row 5 involve conflicts, the requirements that are really important to me. And then making that decision about what to drop it's difficult. It's difficult. So then I really want to consider first those conflicts that are more critical and leave the other one that are not that critical for the end. And this is where the notion of preference play a role. Okay, so now going a little bit more in detail about the definition. So we have a problem P that is composed of constraints that are mandatory. So B are those constraints that I cannot relax. So they got to be in any relaxation. And C are the constraints that are optional. So we can play with those ones in order to get a relaxation. And then, yes, we are going to say that R is a relaxation of C if B union R got a solution. Of course, isn't it? So, and then of course you say, we can infer few things from there. So we know that for us, in order to be able to compute a relaxation, our base itself need to be satisfiable, isn't it? Because if the base is not satisfiable, okay, there is nothing that we can do. Of course, but if the base is satisfiable, of course, there is always a relaxation, because in the worst case, I can just drop them all. Okay, so that's the idea that I want you to keep in mind. And then if we want to find a conflict, okay, we need that the full problem itself got to be unsatisfiable. You know, because if the problem is satisfiable, okay, of course there is no conflict to find. So then, and that's the thing that we are saying in the first bullet. And the second point is the thing that I already explained you. So if we have two conflicts, C1 and C2, and C1 is the one that involves the requirements that are more dear to me, okay, I want to deal with C1 first, because those are the decisions that are going to be more difficult to take, okay? So, but now, how do we define this notion of ordering on conflicts formally? Okay, we have and this is one of the assumptions, yeah, that you might argue actually that, okay, it might not be so realistic, and indeed, there are some cases where it is, and there are some cases where they are not. So we have already discussed in previous talks contests where it really makes sense to speak about lexicographic orders, and this is this is actually meant for those contests. But in reality, we know that no all preference can be expressed in lexicographically. But let's suppose that, okay, we are in the cases where lexicographic is the way to go. So then we have a set of constraints C. Then these are the elements that are in that set of constraints C1, C2, and they are ordered in this order. So C1 is the most important, and Cn is the least important. And now, based on that ordering on the constraints of C, what we want to do now is to define an ordering on set of constraints. And well, one way is Lex, and just to explain intuitively what Lex is. So suppose that you have two sets, X and Y. We are going to say that X is more important than Y if, after removing the elements that we have in common, X got the constraint that is more important. So that is enough condition for us to say, enough reason for us to say, okay, this is lexicographically better. And then there is another ordering, anti-lex, that is the dual. In the dual, yeah, we do something pretty similar. We have X and Y. We remove the constraints that are in common. And then we are going to say that X is more important if Y has the least important constraint, you know? And now I am going to explain where these two orders are playing a role. So they are playing a role in the definition of preferred, conflict, and relaxations. So for relaxation, it is, we want to use lex. For conflicts, we want to use anti-lex. So, and again, the assumption is that P is inconsistent and the constraints in C are totally ordered under less. And then, of course, the role of lex in the computation of relaxation is obvious. Yeah, we basically want to keep those constraints that are more important to us, and that's it. Okay, I mean, it's what you would expect. What is not so straightforward to observe is that we want anti-lex for defining the preferred conflict. You see, so I am focusing in this bullet 3, and suppose that we have this order in row 1, row 2, row 3, row 4, and then we have two conflicts, row 1, row 4, and row 2, row 3. And given that order, it is clear that for us, it is more critical to solve row 2 and row 3 first, because that decision is way more difficult to take. So because in order to solve that conflict, we have to drop either row 2 or row 3. But those constraints are very important. You know, the other conflict is involving row 4 that is actually not that important for me. So for me, taking the decision of dropping row 4, I mean, it's an easy decision because that's the least important constraint. So I don't care much about that one. But about row 2 and row 3, okay, yeah, it is a more complex decision. And that is why under this ordering, yes, well, we want to deal first with row 2 and row 3. This is something that is very important to take into account for the rest. And now, when it comes to computing relaxations and conflicts, yeah, the process is actually pretty straightforward. So there is no rocket science here. So here, what we do is, okay, you know that we explore the constraints in order of importance, isn't it? And then basically, yes, we go from left to right, and we try to add an element if what I have plus that new element that I am trying to add is consistent. If that is not the case, well, I just discard that element and continue. And then, of course, I am going to end up with something that is maximal and preferable, the most preferred relaxation. And for the conflict, we do the dual thing. And you can see it is very easy to observe that both processes involve a linear number of checks. So here, and this is also very important. So here, it is important that you understand that the complexity is not coming from the number of checks that you are performing, but from the checks themselves. Because in real life, we know that these checks are NP complete. You know, because we are dealing with complex satisfaction problem and deciding whether a set of constraints is satisfiable or not. Okay, that is not an easy task. So it is for us very crucial to reduce the number of checks in order to have an impact on the overall, but mostly because the checks themselves are costly. And then from there you also get an idea of how I mean that computing conflicts tends to be more difficult than computing relaxations, because when computing conflicts you are checking for unsatisfiability, and that is yeah, it tends to be harder than just checking for satisfaction. Okay, so how I am doing about time? This is 21. Well, okay, so this is the quick explain. So it's basically doing the thing that I just showed you before for computing conflict, but applying the divide and conquer approach. So I am not going into detail, but if you want details about these hints, you can ask me during the question, because I don't have time now, but I am happy to answer during the question session. But here, what we are doing is dividing the problem in two and exploring first the constraints that are least important. And then going, exploring first the constraints that are more important, and then dealing with the ones that are less important. Basically, that's what we are doing here. So this is just, you know, you are familiar with quicksort. Just imagine quicksort, just apply it to the notion of computation of conflicts. Now, that was about Jonker's paper. So what we did in our lab with these two people over here, with Barry and Deepak, was to go from 2-point relaxations to multi-point relaxations. In short, well, actually, this is based. So this brings good memories, and yes, I should have said this from the very beginning. This topic is about a subject where I haven't published much. There is only this paper and well, and two more papers, and that's all. But I want to change that reality, and that is why I am speaking about this today, because I feel there is a good deal of intersection here with some of the work that people are doing in AVISPA, and I really want to work on this. But yes, so this actually is based on the paper that I presented in AVISPA 5 years ago. So here what we are doing is basically migrating the notion of explanation to QCS, unsatisfiable QCSPs. So yes, the good thing about giving my talk today is that I am coming after Robinson. That's great because he gave a very nice introduction about constraint programming yesterday. So I don't really need to go into the details of constraint programming. So I can assume that all you attended the talk yesterday and not spend too much time here today, but just to give you a summary of what we are going to do now. So basically in normal CSPs, all the variables are existentially quantified. And here, what we are doing is allowing the possibility of having some variables that are universally quantified. So that's basically what we are doing here. So of course, QCSP have applications in many domains, including game theory. For example, yesterday, one question that I didn't dare to ask because it was already 1 a.m. and my brain was not working, was not operational at that time, but I believe it is relevant, is that even for the issue of irrationality, you know, because what we want to basically assume there is that the stuff still works for any possible value of the variable that we cannot control. And then, yes, for me, it looks like a direct application of quantified CSPs over there. And then, of course, now apart from game theory, you can also have applications in designs of circuits, conformal planning, and so on and so forth. Yes, and then, of course, the problem that we are tackling here is once you have a QCSP that is unsatisfiable, what do you do? So how do you explain that to the user? So how do you compute the explanation that is more preferable to the user? So the more preferable conflict. So that's the approach that we presented there. And then in order to motivate, let me take this problem that was presented actually in this paper. It's about checking equivalences of partial implementation. So in here, you have a bunch of people that are working on the implementation of a circuit, and they are starting from an initial specification. And then, of course, as you have subgroups that are working on different parts of the circuits, okay, things can go wrong, you know, because there is a sort of notion of independence over there. So, and then the idea is that, okay, you want to check at an earliest stage whether you have basically going off the road, I mean, taking a wrong path towards the implementation. So you want to detect that early. Okay, so yes, in that paper that I just presented to you in the previous slides, okay, they propose an approach of expressing that check in terms of QCSP. Okay. So let me just give you a very simple example. Suppose that the full design, the full specification is this one, and then, okay, yes, this is a partial implementation, and then we are going to extract the thing that hasn't been implemented with the notion of black boxes. So the black box is basically the stuff that still needs to be implemented, but you want to know a priori in advance if there is indeed a way of implementing those black boxes such that the specification is kept, you know, and you want to detect in advance when that is not the case to say, okay, abort, this thing is not heading into the right direction. Okay, so this is, well, that was a case where obviously there is a way of implementing the black boxes, taking into account that, that specification. And this is a case where you cannot complete the implementation, because this is the specification, and of course there is no way of implementing black box number 2, because in order to implement the functionality that is specified, you need access to X8 that you don't have. Okay, so this is a case where, okay, yes, you need to stop the situation early enough, because it is not going to lead to anything that is going to satisfy the specification. This guy showed that, well, basically they can express that check in terms of QC speed in this way, where, you know, the variables are basically divided in big groups, where B is the number of boxes, black boxes. And then, yes, you want to basically check that for every possible value of the input, there is indeed a value in the output that can be obtained such that the completion is matched. Yeah, so I am not going into the details of that. The important thing is that we have a representation of that in terms of QCSP. And then when that thing is unsatisfiable, you really want to come up with an explanation on why it's not satisfiable. You know, and basically that explanation, that because there can be more than one reason, as we already saw, there can be more than one conflict. So you want to present to the user an explanation that involves the boxes that are more critical to the user. So that's basically it. And now, well, in this part, how much time do I have, Frank? Well, okay.
Luis Omar, te quedan 10 minutos.
Okay, perfect. So then, yes, okay. Well, I am not going to go, so let me just okay, yes. So regarding constraint satisfaction, well, you already know that what a constraint satisfaction problem is. Okay, you have a set of variables, a set of domain associated with those variables, a set of constraints, you know, and then, okay, yes, well, the notion of assignment as introduced yesterday by Robinson is an assignment of values to the variables, and the assignment is consistent, it is consistent with all the constraints involved in the CSP, and then the quantifier CSP, okay, normally we represent that thing in this form. So we have a sequence of quantifications, or quantifiers, and then a set of constraints or defining on a set of variables. And the important thing is that, okay, some of these quantifications are universal quantifications. Okay, so the existential quantification has the normal meaning. So, okay, there is a value in the domain that satisfies the constraint. Okay, we are done. And this is what we are used to in CSP. The universal quantification is the thing that is tough, because now, here we need to guarantee it. We need to enforce that the constraint holds for any possible value of that variable, for that variable. And then, okay, here in the convention is that, yes, as we are going to see, the one way of relaxing unsatisfiable QCSP is by moving that quantification to the left. Then, okay, yes, when the position of the quantifier is not the same as its original position, okay, we are going to use two index I and index J to represent that thing. Okay, now that's basically it. And now, how do we relax unsatisfiable QCSPs? Okay, basically we have three ways of doing that. The trivial one is relaxing the constraints that are involved. And in that case, and our way, so here I am assuming that we are representing the constraints extensionally. So by the set of tuples that satisfy the constraints. And then relaxing a constraint is simply putting more tuples in the set of tuples that satisfy the constraint. So that's our way of satisfying the constraint. And relaxing the constraint completely is basically just saying, okay, the constraint is the Cartesian product of the variables that are involved in that constraint. That's it. Okay. Now, when it comes to universal quantification, we have two options there. The first option is we just reduce the domain of quantification. The smaller the domain, the easier it is to satisfy that requirement. Or we just move that thing to the left. And I am going, this last way is less obvious. You know, so here, yeah, we have this quantification, it is unsatisfiable. This QCSP that is unsatisfiable, and you can see that why it is unsatisfiable, basically because there is no a value for S1 that is related to all possible variable values of X2 such that this constraint holds. That is why it's unsatisfiable. And here we can, there are three ways how we can relax that stuff. So the first way is just, okay, we just relax the constraint. So instead of equality, we just say less than 2. And basically what we ended up doing here was adding more tuples to the set of tuples that satisfy the constraint, isn't it? This is a trivial relaxation. Another way is saying, well, okay, let me restrict further the scope of the universal quantification. So here, instead of saying that X2 is going to be valid for 6, 9, and 10, okay, here is only valid for 6 and 9. This is another way. And the last way is moving the quantification to the left. And here, basically, we are relaxing this. Why? Because we are not enforcing that the same X1 has to be related to all possible values of S2. You see this? So we are saying that for each one of those, there should be one. And so we are trivially relaxing just by moving it to the left. Okay, so yes, so those are our three ways of relaxing unsatisfiable QCSPs. And here we can basically map the definition of minimal conflicts to this context. So here, a minimal conflict in the context of unsatisfiable QCSPs is just a set of relaxations that bring me to a new QCSP that is still unsatisfiable. But if I relax any of the requirements further, then I end up with something that is satisfiable. You see, that's basically, of course, there is a more formal definition of this that I am happy to give also, but I don't have the time, but basically that's the intuition. So you have an unsatisfiable QCSP, you have stuff that you can relax, yeah, and then you relax all those things and up to a point where, okay, you still have something that is unsatisfiable, but you relax any of the other any requirement for them, then the stuff is satisfiable. Okay, so here in this particular example, we see that we have two conflicts, I and I prime, and indeed, if I replace this, the first one basically is telling me, okay, drop the second constraint. The first one is telling me, drop the first constraint. So that's basically the intuition behind each one of those. And then, indeed, if I still apply these two relaxations on the original QCSP, I get something that is still unsatisfiable. And those two are valid explanations for the unsatisfaction of the QCSP. And now the question is, which one do I present to the user first? So assume that this is the ordering that you have on those requirements. So the quantification for you is more important. The most important thing. And then, okay, this constraint is more important than this one. And both of them are less important than the universal quantification. If that is the ordering on your requirements, then okay, you can infer that the user would be more interested in learning about I before than I prime. And that's the intuition behind it.
Or
So
maybe it's good to start summarizing. You have like 3 minutes.
absolutely, yes, I am getting to that point. Thank you, Frank. So then, yes, so far I have spoken about 2-point relaxations. In 2-point relaxation, we are either keeping the constraint or dropping it completely. In multi-point relaxations, you are considering relaxation to the requirement that are not that drastic, you know, so just relaxing a bit, but not completely. So, and then of course, one of the results that we found is that still, in this case, we can compute that quickly enough, but then if you add also preference on the relaxation themselves, okay, the problem becomes complex. Okay, so yes, basically, yes, I spoke about minimal conflicts and relaxations. I show how we go from 2-point to the context of multi-point, in particular, when we are speaking about QCSPs. Yes, it is not there, but definitely I am eager to talk about this further with you guys and find more application for this. That's all.
Muchas gracias, Luis Omar. Ahorita preguntas. ¿Quién levantó la mano o quién quiere preguntar así simplemente?
No quiero preguntar.
Juan Francisco.
Por favor, chicos, sí.
Sí.
Sí, te
Bueno,
escucho, Juan Francisco.
primero que todo, quiero darle la bienvenida a toda tu familia que está por aquí, a Rosario, la vi muy atenta a tu charla. Es un ejemplo de mamá, qué cosa tan maravillosa. Cuando estabas presentando este tema, recordaba las épocas de Patos, cuando estuvimos pues tratando de que Patos funcionara en la Facultad de Ingeniería, y luego apareció de Patos, que era el depurador de Patos, que era para poder darle explicaciones a las secretarías académicas de por qué lo que pedían no se podía hacer y ver qué relajaban para lograr hacer una solución que funcionara. Pues tú lo recuerdas bien porque tú estabas también al frente de esas cosas. Mi pregunta es si todo esto que has mostrado hoy nos solucionaría el problema de esa época.
Bueno, yo creo que sí, excelente pregunta, Juan Francisco, y de pronto podría ser una oportunidad. Es más, porque inclusive recientemente con una de mis colegas acá en el laboratorio se ha reganado pues también interés en el tema de timetabling. Entonces, definitivamente eso sería algo que podemos explorar, ¿sí? Porque hay interés en ambos lados en común y es fácil, sí, porque de hecho la aplicación es directa, ¿sí? Bueno, ahí de pronto lo que sería discutible es, y era lo que mencionaba hace un rato con el tema de los órdenes lexicográficos, ¿sí? Porque de todas maneras ahí sería un poquito difícil de vender el hecho de que sí, nuestras preferencias son lexicográficas en ese contexto, ¿sí? Pero de todas maneras, igual, yo creo que vale la pena hacer el ejercicio para ver qué tanto realmente eso nos aleja de la realidad. Sí, o sea, definitivamente lo importante de estos algoritmos que yo mostré aquí es que son polinomiales en términos del número de chequeos. Sí, entonces definitivamente ahí el esfuerzo va a estar en tratar de resolver los chequeos de satisfacción de manera eficiente. Sí, pero definitivamente hay una aplicación directa y es algo que podríamos conversar con más detalle.
Una pregunta, un QCSP es un, ¿qué digo? Un CSP es un QCSP, ¿cierto? Sin variables.
¿Cómo?
Un CSP.
Exacto, la relación es... Sí, exacto, la relación es CSP.
Un CSP puede ser visto como un QCSP en el que no hay,
claro,
variables cuantificadas.
Claro.
¿Cierto? Y entonces todo esto...
Universales, que no hay universales.
Exacto, y entonces todo esto que hicieron se aplica también a los CSPs normales.
Exacto, me encanta que me hayas hecho esta pregunta porque esa parte no me quedó muy clara en la presentación y me estás dando la oportunidad de aclararla. O sea, ahorita el tema de los QCSP es simplemente una aplicación a la noción de multipoint a two-point relaxations, pero obviamente eso es algo ortogonal, ¿sí? O sea, tranquilamente esta noción de 2 points a multipoints es totalmente aplicable a los CSPs normales, ¿sí? Exacto, todo lo que tenemos es que tener una noción de monotonicidad para saber chequear satisfacción, ¿sí? Pero inclusive esta noción Bueno, ahorita, porque tú sabes que nosotros somos CP guys, entonces, bueno, todo lo queremos asociar con CP. Pero realmente no hay, o sea, tranquilamente uno puede pensar en un contexto en donde los chequeos de satisfacción se puedan resolver en términos de teoría de grafos, ¿sí? En donde sí, o sea, que inclusive eso lo hemos hecho en uno de nuestros papers también, en donde pues sí, o sea, lo que uno hace es, en cada iteración del algoritmo es llamar a un algoritmo de grafo que le dice si la propiedad se mantiene o no. Eso es todo.
Bueno, qué pena con tantas preguntas pendientes, incluso una mía, pero yo prefiero que hagamos la oportunidad también de compartir. Entonces quiero agradecer a Luis Omar y también a la familia. No había visto que estaban todos, veo a la mamá, no veo al resto de la familia, pero
sí,
años
papá.
sin ver a tu mamá, pero años.
Beli te está diciendo ahí, hola, Belisario.
Pero
Sí,
no veo, ¿no tiene
sí,
cámara?
sí, tiene la cámara prendida y no que lo molesta en otro pantallazo, que está conectado desde Chile.
Ya.
Pronto deja de compartir.
Ajá.
Belisario, no manejo Zoom muy bien. Entonces.
Pronto deja de
Yo
compartir
quisiera
la
entonces
pantalla,
agradecer.
deja de compartir la pantalla para que los veamos a todos.
Perdón, no te había entendido, claro, yo soy el que estoy creando el inconveniente, claro. Okay,
bueno,
listo.
entonces en este momento quisiera felicitar a Luis Omar por esta excelente presentación, muy interesante, y podemos